Welcome to this online course. This course is the quantitative research method. This is week 8, hypothesis test part 1. I'm the instructor, Chong Kwang Ho from the Kunshan University. Okay, so let's go to the course, the outline. Okay, so the hypothesis test part 1 we will cover. First one, developing null and the alternative hypothesis, and the second is type 1 and the type 2 errors, and the third one is one-tail test about the population mean large sample case. Okay, so let's go talk about the hypothesis test. Okay, hypothesis testing can be used to determine where a statement about the value of population parameter should not be rejected. And the null hypothesis denoted by HDO is a tentative assumption about the population parameter. And the alternative hypothesis denoted by HA is the opposite of what is stated in the null hypothesis. So the hypothesis procedure uses data from a sample to test the two competing statements indicated by H0 and HA. Okay. So this chapter we will talk about the hypothesis test, and also we have do some example in the Spss. Okay, and also I already give you the sample data file. And so we can run Spss later. Okay, so the next slide is that we will talk about developing null and the alternative hypothesis. It's not always obvious how the null and the alternative hypothesis should be formulated, and the care must be taken to structure the hypothesis appropriately so that the test conclusion provide the information the researcher wants. Okay. The context of situation is very important in determining how the hypothesis should be stated. And in some cases, it's easier to identify the alternative hypothesis first. In other cases, the null is easier. Okay. So the correct hypothesis formulation will take practice. Okay. So we state the null hypothesis H0 is tentative assumption about the population parameter, such as population mean or population, and the alternative hypothesis HA is the statement that is the opposite of what is stated in the null hypothesis. Okay. Okay, so if you decide to do the quantitative data analysis in your thesis, so maybe you need to think about what's your hypothesis. Maybe it come out to your research topic, and also you can looking for some journal article. Maybe they have they already have do some hypothesis test, so you can check. Maybe you can use their idea to do the research in your thesis. Okay, so next, many applications of hypothesis testing involve attempt to gather evidence in support of research hypothesis. Okay, so in such case, it's often best to begin with the alternative hypothesis to make a conclusion that researchers hope to support, and the conclusion that the research hypothesis is true is made if the sample data provides sufficient evidence to show that the null hypothesis can be rejected. Okay, so when you do the thesis, you must come out to the hypothesis, and also after you finish your data collection, and you type the data and run the data and analyze the data, so you can find maybe you will reject H0, the null hypothesis, and then you find your result. Okay. Okay, so this is the first example. Okay, so before we do the SPSS, we can first we talk about the question. Consider particular automobile that currently attain a fuel efficiency of 24 miles per gallon in the city driving. A product research group have developed a new fuel injection system designed to increase the miles per gallon rating. The group will run control tests with the new fuel injection system, looking for statistical support for the conclusion that new fuel injection system provide more miles per gallon than the current system. Okay, so several new fuel injection units will be manufactured, installed in test automobile, and subject to research controlled driving conditions. And the sample mean mile per gallon for each this automobile will be computed and used in the hypothesis test to determine if it can be concluded that the new system provides more than 24 miles per gallon. In terms of the population mean mile per gallon mu, the research hypothesis mu larger than 24 become the alternative hypothesis. Since the current system provides the average or mean 24 miles per gallon, we will make the tentative assumption the new system is not any better than the current system. Choose the mu less than the 24 as the new hypothesis, and the alternative hypothesis are okay. So the new hypothesis, the mu is less than the 24, and the alternative hypothesis mu is larger than the 24. Okay. Okay. So if the sample result lead to the conclusion to reject HDO, the inference can be made that HA mu larger than 24 is true. The researchers have the statistical support to state the new fuel injection system increase the mean number of miles per gallon. The production of automobile with the new fuel injection system should be considered. However, if the sample result lead to the conclusion that H0 cannot be rejected, the researcher cannot be conclude the new fuel injection system is better than the current system. Production of automobile with the new fuel injection system on the basis of better gas mileage cannot be justified. Perhaps more research and further testing can be conducted. Okay, so the next example, we can see the alternative hypothesis, a research hypothesis. Example, a new teaching method is developed that is believed to be better than the current method. An alternative hypothesis, the new teaching method is better. And the new hypothesis, the new method is no better than the old method. So this is the opposite. So you can see the alternative hypothesis, they want to prove the new teaching method is better, and the new hypothesis is old method is better than the new teaching method. Okay, so this is the opposite hypothesis. Okay, so another example, a new sales force bonus plan is developed in an attempt to increase sales. Okay, so alternative hypothesis, the new bonus plan will increase sales, and the new hypothesis not increase sales. Okay, so this is the hypothesis. Okay. Another example, a new drug is developed with the goal of lowering blood pressure more than the existing drug, and the alternative hypothesis, the new drug lowers blood pressure more than the existing drug, and the new hypothesis is no lower. Okay, so this hypothesis. Okay, so We might begin with the belief assumption that a statement about the value of population parameter is true, when then you use the hypothesis test to challenge the assumption and determine if there is statistical evidence to conclude that the assumption is incorrect. In this situation, it's helpful to develop a new hypothesis first. Okay, so another example, new hypothesis assumption to be challenged. Consider the situation of a manufacturer of soft drink product. The label on the soft drink bottle states that it contains 67.64 ounces. We consider the label correct provided the population mean field weight for the bottle is at least 67.6 ounces. Without any reason to believe otherwise, we would give the manufacturer the benefit of the doubt and assume that the statement provided on a label is correct. Thus, in hypothesis test about the population mean flow weight per bottle, we will begin with the assumption that label is correct, and they state the new hypothesis as the mu larger than and equal large 67.6. The challenge is to the assumption which imply the label incorrect and the bottle are being underfilled. So this challenge would be state the alternative hypothesis mu less than the 67.6. Thus the null and the hypothesis are. Okay, so we can see the new hypothesis. The label is correct. The mu is large than and equal with the 67.6 ounce, and the alternative hypothesis label incorrect. Mu less than 67.6 ounce. Okay, so we can see the equal sign is in the new hypothesis. Okay, so 67.6, this is the limit. So you must we want to find is larger than the 67.6. Okay, this is new hypothesis. Okay, so a government agency with responsibility for valid manufacturer label could select a sample soft drink bottle, compute the sample mean field weight, and use the sample result to test the preceding hypothesis. If the sample result leads the conclusion to reject H0, the inference that the HA mu is less than the 67.6 is true can be made. With the statement support, the agency justified in conclude the label is incorrect and the underfill of the bottle is occurred. Appropriate action to force manufacturer to comply with label standard would be considered. Okay. So, however, if the sample result indicate H0 cannot be rejected, the assumption that the manufacturer label is correct cannot be rejected. With the conclusion, no action will be taken. So now maybe you a little bit understand why we talk the hypothesis test. So we have the two hypothesis statement. This first is HDO, and this called the new hypothesis, and another hypothesis is HA. This is we call the alternative hypothesis. So this example, if the label is correct, we need to prove this mu. This is much larger than the 67.6 ounce. If the label is not correct, we need to prove the mu is less than the 67.6 ounce. Okay, so this hypothesis have the three kind of condition. You can see in this slide. The equality part of hypothesis always appear in the new hypothesis equality part. Okay, in general, hypothesis tests about the value of population mean mu, must taken one the following three form, where mu 0 is the hypothesis value of the population mean. Okay, so you can see the H0, the first condition, H0 mu larger than and equal mu 0, and HA mu less than the mu 0. This is the we call one tail, and this is the lower tail. Okay, because we want to. This is HA. This is the left side. The mu 0. This is the left side, and H0. This is the right side. So this we call lower tail, and the HA mu less than and equal mu 0. HA is the mu larger than mu 0. So this is the upper tail. Okay, and the third condition, H0 mu equal to the mu 0, and the HA mu is not equal mu 0. So this is the two tail. Because this is the both side. This is the two tail. Okay, so this slide is the one example. So this is the metro. This is the transport. This is the you can see this is the company. A major West Coast city provide one of the most comprehensive and emergency medical service in the world, operating the multiple hospital system with appropriate 20 mobile medical unit. And the service goal is to respond to medical emergency with the mean time of 12 minutes or less. And director of medical service want to formulate a hypothesis test that could use the sample emergency response time to determine whether or not the service goal of 12 minutes or less is being achieved. Okay, so you can see the 12 minutes is the director want to do this proof. So 12 must be the board. Okay. So on the next slide you can see the H0. This mu is less than and equal 12, and HA alternative hypothesis the mu larger than the 12. So the emergency service is meeting the response goal. Okay, so no follow-up action necessary. So we can see the question again. Okay, so the service goal is response to medical emergency with the 12 minutes or less. Okay, so you can see the H0 mu this the less than the 12. So we want to prove this the minutes must be less than or equal than 12. Okay. Okay, so another slide we will talk about the type 1 error. Because hypothesis tests are based on the sample data, we must allow for the possibility of errors. Okay. A type 1 error is reject H0 when it's true. So this is we can see this is the type 1 error because if H0 is true but we reject, this must be the type 1 error. And the probability of making a type 1 error when the new hypothesis is true as equality is called the label of significance. And we will talk about the p value. And the application of hypothesis testing that only control for the type 1 error are often called the significant test. Significant test. Okay. So another type 2 error. A type 2 error is accept H0 when it's false. So you can see the type 1 error is reject H0 when it's true, and the type 2 is accept H0 when it's false. It's a little bit different. It's difficult to control for the probability of making a type 2 error. Statisticians avoid the risk of making the type error by using do not reject H0 and do not accept H0. Okay. So this is the table we can see. This is you can see the population condition and the conclusion. So you can see when we accept H0, when H0 is true, so this is correct. And we can see we reject H0, and reject H0, we say the HA is true. This is correct conclusion. Okay. So you see the type 1 error when we reject the H0, H0 is true. So this is the type 1. And when we accept the H0, accept 0, when the HA is true, this we see this is the type 2 error. Type 2 error. Okay, so this is the example we already talked about. We call the hypothesis test discussed in the previous section. Automobile product research group developed a new fuel injection system designed to increase the miles per gallon rating on the particular automobile. With the current model obtain an average of 25 miles per gallon. The hypothesis test formula this: the H0, the mu is less than and equal to the 24, and the HA is the mu is larger than the 24. So the HA mu is larger than 24 indicate the researchers are looking for sample evidence to support the conclusion, and the population mean mile per gallon with the new fuel injection system is greater than 24. Okay. So we can see the type 1 error. We reject H0 when it's true. So you can see the corresponding researcher claim that the new system improved the mile per gallon. This the mu larger than the 24. When in fact the new system is not any better than the current system. So this is we can see the type 1 error. Okay. So this is the researcher, they prove the new system is better than the current system, but in fact the new system is not better. Okay. And in contrast, the type 2 error is accept H0 when it's false. So corresponding researcher conclude the new system is not any better than the current system. The mu is less than the 24. In fact, the new system improved. Okay. Okay, so for the miles per gallon rating hypothesis test, the new hypothesis H0 mu is less than and equal 24. Suppose the new hypothesis is true and the equality, then mu is 24. Okay. the probability of making type 1 error when the new hypothesis is true as equality is called the label is significant. Okay. So now we will see the definition of the label of significant. The label of significant is the probability of making type 1 error when the new hypothesis is true as equality. The Greek symbol alpha is used to denote the label of significance, and the common choice for the alpha are 0.05 and 0.01. So this is the choice. So we can call the p-value. P-value is the label of significance. Okay, so the p-value is the probability computed using the test statistics. They measure the support or lack of support provided by the sample for the new hypothesis. If p-value is less than or equal to the label of significant alpha, the value of the test statistic is the injection region. Less than or equal, and the value of tested in the rejection region. Okay, so reject H0 if the p-value is the less than and equal to the alpha or equal to alpha. Okay, and the p-value approach use the label test statistic D to compute a probability called the p-value. Okay, so you can see the test statistic about the population mean, the alpha, the data known. So you can see the data. This is the data is the standard deviation, and the n is the sample size, and the x is the mean value, and the mu 0. Okay, this is the formula. We can calculate the d value. So you can see the d to compute the probability. This is the p-value. Okay, so let's continue to do some practice with the example. This is a case. Let us now compute the p-value for the here top coffee lower tail test. Suppose the sample of 36 this coffee can provide a sample means is the 2.22 pounds, is the mean value that is the 2.92 small enough to cause us to reject HDO. Okay, the sample mean. So this is because this is a lower tail test, the p-value is area under the standard normal curve for the value of d less than the value of the test statistic. Using the sample mean is the 2.22, and the standard deviation is the 0.19, and this sample size is the 36. We compute the value of the test statistic d. So the next slide, you can see the d is equal. This is the mean value x minus mu 0, and divide by the delta, and divide is the square root n. Okay, n is the sample size. Okay, so we can get the negative 2.67, this number. Okay, so we can check the standard normal probability table. We can see this value is the number is the 0.0038. So the p-value this is the p-value. Okay, so this is the p-value is the, we can see the is the lower, we can see that this alpha, this is the less than the 0.01, so we reject H0. So did you remember this in here? We already talked about the alpha value. This is the 0.05 or 0.01. We can choose these two. So you can see the negative 2.67. This is the less than the 0.001. Oh no, this is the p-value. This 0.0, this is less than the 0.01. So we reject. So we can see this one. So this p-value is less than the 0.01 or 0.05. This we reject H0. Okay, so any question? Okay, so we can see this graph. Okay, so let's see, maybe we have the data. This is the week A, so you can check the folder week 8. So we have the copy this Excel file, so we can use this one. Okay, the weight, we have the 37, so we can see we have the 36. Okay, so we can copy into the weight. Okay, so let's go to the SPSS. So this software is the school already buy the license. So this is the legal. We use in this course. This version is the IBM SPSS statistic 25. This version. Okay. Okay, so let's open the new data. Okay, so you can see we have the data view, variable view. So first one, we have the variable view. We call the weight, the one variable. Weight, okay, and the decimal is either 2, okay. Okay, so this is the weight. Okay, and now we can insert the data. Okay, we copy from the Excel, this file. We have the 36. Okay, so we can copy, paste. Okay, so now we can run in the SPSS. So you go to the analyze. Okay, analyze. And you want to do the compare mean. Okay, hypothesis. Okay, descriptive, compare mean. Okay, independent. So we can take okay. So let's go to the SPSS. So you can see that we have analyzed. We can see the frequency, already know frequency, statistic. You can do the mean, median, mode, and also the standard deviation, and the minima, maxima, and we can have this number. So we can see. So you can see the mean is a 2.22. So we can check this one. 2.22 or and we can check the standard deviation is 0.18, or you can see the output standard deviation. You can see the 0.16. Okay, that's a little standard deviation. Standard deviation. Okay. So let's go to the simple table and compare means equation. Okay, so let's go back to the slide. Okay, so then you can do this one, descriptive, and also the descriptive. Also, you can do the maybe we do the frequency, statistic, format, okay. Okay, so you can see in the SPSS we already have a lot of function. Okay, so here we back. Okay. Simple. Okay. So you can try his a lot of function. You can see the independent sample. Okay. This one. Okay, so let's go back to the slide. So you can see why we say is the lower tail test, because you can see this line. We can see this mean this sample mean is the 2.22. You see the left side and the right side. We want to prove this is this side, so you can see this the lower tail. Okay, is the left side. Okay, so the left side is the lower tail. Okay, so let's go to the next slide. So now we can state a general rule for determining whether the null hypothesis can be rejected when using the p-value approach. So rejection rule using the p-value, reject H0 is p-value less than or equal to this we call alpha. Okay. So this test p-value is the 0.0038 result in the rejection of the null hypothesis. Okay. So the H0 we reject. And the suggested guideline for the interpret p-value is if the p-value is less than the 0.01, the overwhelming evidence to conclude HA is true. And if the value between the 0.01 and the 0.05, strong evidence to conclude HA is true. If the value is between 0.05 and the 0.1, weak evidence to conclude HA is true. If the p-value is greater than the 0.1, insufficient evidence to conclude HA is true. That means that H0, we didn't reject H0. Okay, so another one is the two-tail. You can see the two-tail is the equal or not equal. This means two-tail. Okay, and another example, we can see this scope of association, and this is the company. I already give you the data. You can check in the folder. We have 295. This they need to use the high technology manufacturing process to produce a golf ball with a mean driving distance. This one. And you can see the HDO is the mu is equal 295. HA mu is not equal 295. Okay. Okay, so the question is if the sample mean is significantly less than the 295 or greater than the 295, we reject H0. Okay. Because the H0 is the sample mean is the equal and 295. Okay. And the sample size the 50, and the standard standard deviation is the 12, and you can see the 1.7 standard error. So you can see the p-value. The p-value is first we can check the d-value is the 1.53, and the p-value we can check the distribution. This table is the 0.93, so this is the larger than the 0.01. Okay. So the new hypothesis should be reject. Okay. We didn't reject hypothesis. Okay, because the 0.12 is larger than the 0.05. Okay. So you can see this table. This is the lower tail and upper and the two tail test. Okay, so this is the hypothesis, and the test statistic is the d value. Okay, so this is the we will talk about. Okay. Okay. Okay, so let's go to another example. This is one tail, and the population and the data is unknown. So this is you can see the sample. This is the highway patrol. This vehicle speed and various location. Okay, so the vehicle speed is used to test the hypothesis H0, the mu is less than the 65. Okay, so H0 is rejected. Okay, so the 64 show the mean speed, and the standard deviation is 4.2. This is the delta. Okay, and the alpha, the p-value is the 0.05 to test the hypothesis. So how do we correct? The first one, we see the H0, the hypothesis H0 must be less than the 65, and the HA, the mu is the larger than 65. Okay, and the label significant, in the question they give you the alpha is the 0.05. Okay, and the compute, the first we check the d value. The t is the equal the x already 66 to point the mean speed. Okay, and the minus, this is the 65 already give us, and the x we can see the 4.2. This is the standard deviation, and multiply by divide by the square root. Okay, 64. This is the sample size, and we can get the 2.286. Okay, so we check the table. Okay, we can see the 2.26. The p-value is the so we can see so p-value is the 0.01 to 0.025. Okay, so the result we reject H0. Okay, okay, so this is an example. If you have time, you can just do the practice. Okay, so this is today this course. So the next week we will go through the hypothesis test. It is the part 2. Okay. and also we will do some practice in the class. Okay, so any question you can use the online this platform, and we can maybe in your discussion we can ask me the question. I will respond you as soon as possible. Okay, so see you next week.